Hello all. Today we are doing a question from, yes, capacitors. It's a capacitor question. So the question will appear very soon, so you can see the real question. Actually, what we have to do is we have to find the charge at each capacitor. So here we have C4, C5. Let's say this is C1, C2 and C3, C4 and C5. So we need to find the potential, we need to find the charge at each capacitor, right? So give it a try and come back later. You should do the question first. If you can do the question, that is great, right? Now let's get into the question. I hope you have done it now. If you could do it, yes, that's great, right? So just by looking at the question, what we can see, if you have trained your eye, actually you might see the shape of a Wheatstone bridge here. We have 4 capacitors here, and in between we have another capacitor there. So it looks like a Wheatstone bridge, but it's not exactly. But remember that we have to check the, what do we have to check? We have to check, is there any, yes, ratio connection. So here the ratio, potential difference ratio, actually we don't have to use Wheatstone bridge here. Even if we are using Wheatstone bridge here, we need to apply it like this. But anyway, the potential difference, hope you can see, it's 6:3 and 3:6. So either way, we cannot apply Wheatstone bridge concept here. So then what we have to do is we have to do the question in a normal method, right? Let's start with this C4 and C5 capacitors. Initially what I am doing is I'm making this point grounded. So the potential at this point is 0, potential at C0, potential at this point is 0 as well, right? So then potential at A, at this position, the potential also that becomes 10 volt, right? It's 10. So now what I can see is potential difference across A and C, that is 10. We have 10 potential difference across C4 and C5. So what I have to do is I have to, yes, allocate the potentials for C4 and C5. Basically the potential difference across AC is 10. So I'm allocating the potentials now. So what is the connection? You should know the connection. The potential difference and the capacitor connection is capacitance. Let's write it down. Q equals CV. So V equals Q over CV proportional to 1 over C. That you should know. Right. So let's do the calculation now. C4 and C5, the potential ratio, let's say V4 is to V5, should be equal to 1 over 3 is to 1 over 6. So I'll make it a proper connection. So what I'm doing is I'm multiplying it by 6. So it's 2 is to 1. This is the ratio. Actually we need to distribute the potential. So the given potential is 10 volt. So what I am doing is, so I'll take the fraction here. It's 2 over 3 and it's 1 over 3. So what I have to do is I have to multiply this value by the potential given. So it's 10 into 2, that's 10 into 1. So 20 divided by 3 volt. I hope you can see here, and it's 10 divided by 3 volts. So now we know the potential difference across C4 and C5 as well, right? So what we have to do is we have to multiply the values now. Let's apply the equation Q equals CV. So here C is 3 microfarad, remember that. So 3 into the potential difference across C4, it is 20 over 3, you can see that. So 20 over 3. So we get 20 micro coulomb, right? I think you cannot see it, but it will appear here very soon. So, right, then let's move into the other one. Q equals CV for C5. So C is 6 microfarad, that into 10 over 3. So we get 6, 20 again, 20 microcoulomb. It must be equal. These two are in series anyway. So it's 20 microcoulomb for C4 and C5. Now let's move into the other 3 capacitors. Let's start with, actually we have to keep it here anyway. We need to do certain things actually to find the potential difference across the 3 microfarad capacitor, these two are. So let's find the potentials of C1 and C2 first, and then we can move into the last capacitor for sure, right? I hope you remember we got the potential here 20 over 3 and here we got 10 over 3. That of course we know. If the potential here is 0, that means potential at D it is 10 over 3 volt. This will come in handy for sure. So we are needed to remember this. Right. Moving into the upper part of it. Right. Here again apply the very same method. Let's apply Q equals CV. Here V proportional to 1 over C method. So potential ratio is equal to the resistance capacitor ratio 1 over 6 is to 1 over 3. In the same manner we are multiplying it by 6. So I get 1 is to 2. So it's 1 over 3, 2 over 3 the ratio. And let's multiply it by 10. Again the potential difference is here 10. So the potential difference across these two, that is also 10. Now we know that. Right. Let's multiply it by 10. So again we are getting 10 over 3 and 20 over 3. So here we get 10 over 3, here we get 20 over 3. Let's apply Q equals CV, right? C is 6 microfarad, remember that. That into 10 over 3. Again we are getting 20 microcoulomb. And for the other one, C2, again that 3 into 20 over 3, again 20 microcoulomb, right? So 20 microcoulomb, 20 microcoulomb. Here also we got 20 microcoulomb and 20 microcoulomb. Finally, moving into finding C3, right? Charge C3, right? So for this actually we need to find the potential difference across the capacitor. So how do you find the potential difference? Now we know the potential here. So we need to find the potential at B, right? Now we know C2 capacitor that is holding, yes, what's the amount? 20 over 3 potential. So here the potential difference across this capacitor is 20 over 3. So the potential at B, it has to be 20 over 3 volt. Here it's 10 over 3. So what's the potential difference now? 20 over 3 minus 10 over 3. I hope you can see the difference now. It's 10 over 3 volt. Potential difference across C3 capacitor. So let's apply our equation now. Q equals CV. C is 3 and V is 10 over 3 and we are getting 10 microcoulomb. The last answer for C3. Now we have all the values, right? Students, this question is a bit different from the other question. I hope you saw it actually. So we are getting at least one question, one MCQ question in our MCQ paper from capacitors. It's always better to be practiced with these type of question. And question we can do the question is very easily, and the time, it won't take time actually. It's very quick question. So give it a try for this question. It will come in handy for sure.